Radiation in Medicine. Risks and Protection, 3. By Assistant Professor of Medical Physics, Dr. Al-Arif. Radiation Protection Objectives. The specific objectives for radiation protection are: 1. To prevent the occurrence of clinically significant radiation-induced deterministic effects by keeping the dose limits below the threshold level. 2. To limit the risk of stochastic effects, example, cancer and genetic effects, to a reasonable level. To achieve those objectives we must control the radiation exposures as low as possible by applying the Al-Arif principles. Note, Al-Arif comes from the first letter of as low as reasonable achievable. The Al-Arif principle. It aims to make every reasonable effort to maintain exposures to ionizing radiation as low as possible. This can be achieved using number of procedures. 1. Time. This concept is used to limit radiation dose by reducing time of exposure. The total dose is calculated by multiplying the dose rate emitted from the source by the time of exposure as shown in the following formula. Total dose equal exposure time x dose rate. Solved example. Please follow the solution carefully. 2. Distance, the inverse square law. It is well known that radiation dose reduced as we move away from the source. This reduction is inversely proportional with the square of the distance from the source according to the following inverse square law formula. The ratio of the dose, d sub 1, at distance r sub 1 from the source to the dose d sub 2 at distance r sub 2 equal to the square the ratio of r sub 2 divided by r sub 1. This is so called the inverse square law. Solved example, please follow the solution carefully. 3. Shielding and design. Shield is a protective material that is able to absorb radiation. It placed between radiation source and the individual. There are two things to be considered when designing any shield: 1. Type of material used. 2. Amount and cost of material used in the shield. To calculate the required thickness of the shield, we use the following exponential attenuation formula: d sub x equal d sub 0 multiplied by the exponential of minus mu multiplied by x, where d sub x is the radiation dose at depth, x, mu, in centimeter to the power of minus 1, is the attenuation coefficient of the absorbing material, represent the ability of the material to absorb radiation. Exercise. Please read the exercise and try to answer according to your recent knowledge before looking to the answer in the below right corner. Problem. Please solve the problem and check your result with the given answer.